So we're continuing in chapter 9, and this is the next section on the idea of measurement. And so in this section, we're going to be looking at measuring area and volume. Need my pencil ready. There we go. All right. So our objectives for today are to understand the idea of square units to measure. We're also going to pay attention to dimensional analysis of how to change units with respect to area, and then also cubic units. So this will be very similar to last section. The difference being is with areas, you're going to be multiplying to find areas and to find volumes. And so we have to be careful with our units in that regard. And then we'll also look at conversions between these in terms of carrying capacity or measuring capacity. Okay. All right. So let's dive in. So a square unit is an area. It's a unit of area. So if you have, for example, maybe your home or your apartment or your living space is measured in square feet, for example, would be a very common one. That would be 1 foot like this by 1 foot like this. And so this area that you measure out here would be the size of that unit square of feet. Another common one is square inches. We talk about square inches a lot, usually with their smaller things. You may talk about like pressure. Pressure is a common measurement that you may hear about. Pounds per square inch, for example, maybe something that came across like with bike pressure or tire pressure in general. I was thinking like a basketball, pumping up a basketball or pumping up your bike tire. You talk about pounds per square inch. So that's a pressure, but it's the pressure measured against a unit of a square inch. Square centimeters are very common in like very small areas. Art, I see that a lot. It's a unit often associated in my experiences with art, palette size, stuff like that. Okay. But notice that each one of these is a square. Okay, so it's the same length as width. And so the multiplication of the length times the width gives us the total area of this square. Okay, so we can count square units to figure out the area. So if I just started counting here, we'd have 1, 2, 3, 4, 5, 6, 7, 8. That's an 8, 9, 10, 11, and 12. Okay. And that took a while, and that was only 12, right? So there's got to be a faster way. And so some clever folks may recognize that isn't that 3 on this side? And isn't that 4 on this side? And so can't we just say that the area of this entire thing is 3 times 4, which is, of course, 12, and you would be right. But notice that these are measurements of length, so we need to include some unit here. So I'm going to use U as the universal demarcation for unit. And so it's not just 3 times 4, it's actually 3U times 4U. In other words, the units are being measured. And so you get U, and if you have the same number like 3 times 3 is equal to 9, that's a perfect square. So, which is the same thing as 3 squared. And so U times U gives me that this is 12 square units. This is read 12 square units, okay? Which is what we're talking about here. All right, so for a square foot, for example, when we compute that in terms of, let's say, a smaller measurement, if we wanted to compute it in terms of the inches here instead of the full square foot, okay, then what we're going to do is we're going to create an array, and then we could count up 1, 2, 3, 4, all the way across, and we'd end up with 144. But that's a lot of counting. And so it's much more efficient for us to recognize that, oh, I can just multiply this 12 times 12, and that would give us that the total area is 144 square inches. Okay, but we can compare this if we wanted to convert each of these lengths into from feet. This is 1 foot here, and this is 1 foot here. And so if we look at 1 foot times 1 foot, that's the area of this square. Okay, and it's the same as this area. Those are both the same areas. But we wanted to convert feet to inches. Then we have 12 inches. Again, the unit that we want on top divided by the 1 foot on the bottom. And I have to do this 2 times because I have 2 conversions. I have 1 foot. So this part right here was for this top part, and then this part right here is for this side here. So I have 1 foot. I want it in inches, so there are 12 inches in 1 foot. Okay, and so the feet cancel, and I'm left with 12 inches times 12 inches, which is going to give us then the 12 times 12, or 12 squared inches being the unit squared. Okay, but 12 squared is a number we can compute, and that's 144 then inches squared, or 144 square inches. And so notice here that because we have one length this way and one length this way, I need to make a unit conversion if I'm going to convert between units. And then I can carry out the multiplication of the common units once they're all in the same, or expressed in the same units. We wouldn't want to measure one in inches and one in feet. Those are different units, and again, making that comparison, that would be some strange amalgamation of units that we wouldn't really know even what that meant. Okay, so that's why we want to make sure that we're converting between units so that we're comparing the same size of things. Likewise, this is what we're doing here. So if we had 1 yard, and we wanted to know what it was in feet, we convert 1 yard is 3 feet. And if we wanted to know what the area of 1 square yard was in feet, then we could multiply, or in this case, we would count, but it would be the same thing as multiplying 3 feet times 3 feet, which gives us then the 9 square feet. So 1 square yard is the same thing as 9 square feet. All right, so here's some other common measurements that we use in converting between areas. So 1 square foot is 144 square inches. 1 square yard is 9 square feet. 1 acre is 43,560 square feet, or 4,840 square yards. And 1 square mile is about 640 acres. Okay. Out here where I live, I drive in the country, and there's a lot of square miles. So in between county roads, for example, those are typically a length of 1 mile. And if you went down the other pathway, that would also be a mile. So in that square mile, there would be a total of 640 acres. So it's kind of a neat little thing to recognize. All right. Using square units to compute population density. So that might be something you're not expecting, but it's a common trait that we use to kind of talk about how populations are dispersed over an area. Okay, so in this example, after Alaska, Wyoming is the least densely populated state. The population of Wyoming is 568,158 people, and it has an area of 97,814 square miles. So what is its population density? Well, that would be the number of people per square mile. Okay, so population population over area. That's what it's saying here. So we have 568,158 people divided by the 97,814 square miles, which gives approximately 5.8 people per square mile. Okay, so roughly almost 6 people per square mile. And remember, a square mile is 640 acres. So that's not a lot of people per square mile. Of course, now there's a lot of mountains on the western side and stuff like that. So it's not like it's all perfectly habitable land. However, it kind of gives you an estimation of like the population distribution on average throughout the state. All right. English and metric equivalents for area. So 1 square inch is 6.5 square centimeters. 1 square foot is approximately 0.09 square meters. 1 square yard is approximately 0.8 square meters. 1 square mile is 2.6 roughly square kilometers, and 1 acre is about 0.4 hectare. This is where I was referring to earlier, where the hectare comes into play. Sometimes you'll hear that relationship with respect to acre versus hectare. Acres are an SI, are not an SI unit. Hectares are. All right. Let's see. Using dimensional analysis on units of study, a property in Italy is advertised as $645,000 for 6.8 hectares. Find the area of the property in acres. Okay, so what is this question asking us? It's giving us the price for 6.8 hectares. Okay, so that's more than 1 acre, hectare. Hectares. I think I was saying hectares. Oh my gosh, that's funny. Hectares, sorry. So 6.8 hectares. So find the area of the property in acres. So we have, we don't really care. We don't really care what the price is. That's kind of a distractor. What we do care about is the size of it. So there's 6.8 hectares. And so hectares, sorry, I keep calling them hectares. There's which is equivalent to 0.4 hectares for 1 acre. Okay, so if we take the 6.8 hectares, we want acres on top, so we want to get rid of the hectares, and so we put 1 over the 0.4 hectares. That'll cancel out the hectares, and we're left with 6.8 times 1 acres divided by 0.4 with the hectares canceling out, which gives us approximately 17 acres. Okay, so that's a pretty good sized chunk of land in a different measurement. All right, using dimensional analysis for units of area, what is the price per acre? So this is a very common thing that you'll see if you ever go to like a new place, right? Or if you're ever in your own neighborhood. If you ever look at, I think Zillow has them. You can look at different government websites have the price per acre. And certainly if you buy like a home or something like that, you can look at like median prices of homes or the cost per square foot, even in rental, rental apartments and stuff like that. They sometimes have that number listed. All right. So what is the price per acre in this example of the Italian piece? Well, there's $547,000 for the total of 17 acres. So if we take the $545,000 and divide by 17 acres, then that gives us then that 1 acre costs $32,059. All right. So measuring volume is very similar to measuring area. However, it's a volume is an area with an extra dimension measured in it. And so volumes refer to the space inside. So for example, my coffee cup, the area of the cup, if you can imagine this, if this didn't taper down, but it was the same length, this is the area of it. And if it was a perfect cylinder where it didn't taper down, then this cross-sectional area would be the area all the way down its length. But the volume would be the area multiplied by the how high I stack those areas. Okay, and so the volume is the amount of liquid I can put in here. The area is the space of the like when I set this down, like how much space it takes up. Okay, and so 1 cubic foot is 12 to the third cubic inches, or 1,728 cubic inches. 1 cubic yard is 27 cubic feet. Let's see. Measuring volume, what is this, the volume of this solid? So you can count cubic units just like you could count inches, right? Or you could count feet. So you're just counting them in each dimension, right? You're counting it this way, you're counting it this way, and then you're also counting it this way. Okay. So let's look at this. What is the volume of the solid? Well, let's start counting the cubic units, right? And so I have 1, 2, 3. Now notice this one right here is the same as this one right here. So I don't need to count both of those, right? So it's just 1, 2, 3, 4, 5. And if you can imagine on top here, one, that's like counting this one here, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So there's a total of 9 cubic units on this top bunch, and then there's 9 more on the bottom. So the total amount then would be 18, which there you go, is 18 cubic units. Okay. All right. So talking about capacity, here are some common measurements. The amount of fluid in a three-dimensional object can hold is often called its capacity, which is a reflection of its volume. So 1 cup is 8 ounces. 4 quarts is 1 gallon, like a gallon of milk, which you may be familiar with. 1 gallon is 128 ounces, and 1 cup is 8 fluid ounces. So there's a confusion there often between ounces and fluid ounces. So just be careful of those. You have to know what you're talking about. Which one is it? So oftentimes, like on On bottle measurement things, you'll see like FL, OZ, for fluid ounces versus OZ for ounces. Okay, volume in cubic units. You have 1 cubic yard. It's about 200 gallons. 1 cubic foot is 7.48 gallons, and 231 cubic inches is about 1 gallon. Okay, so I think probably the most common one might be the cubic foot to gallons relationship. I think that I've seen out there, but it's good to know that, or at least know how to reference where those are at. Okay, so volume and capacity in the English system. In this case, we have a swimming pool that has 22,500 cubic feet of volume. How many gallons of water are needed? So this is the capacity to see how much water we need. So using this relationship here, what do we have? We have cubic feet. What do we want? We want gallons. So which one talks about cubic feet to gallons? Oh, that's this one right here. Okay, so we put 22,500 cubic feet. Cubic feet go on the bottom. We want gallons on top. The gallons can or the feet cancel. The cubic feet cancel, and we left with 22,500 times the 7.48 gallons, which is approximately 168,300 gallons of water. It's quite a bit of water, but that's about normal for a standard size pool. All right, units of capacity in the metric system. Okay, so here, some of these may sound familiar. The US has adopted some of these and others much less so. So we have a kiloliter, a hectoliter. I sometimes hear this in terms of like reservoir capacities, like the water being held behind a dam. Not very often, but sometimes. A liter you certainly would be familiar with if you are familiar with like 2 liters of soda, right? Or a liter of, you can get it like a gas station or whatever. A deciliter you maybe heard of. Centiliter, you may have heard of, and milliliter you may have heard of, especially if you're in the medical fields. Medical fields tend to refer to milliliters and centiliters, or cubic centimeters as well. So 1 milliliter, 1 cubic centimeter is 1 milliliter. All right. Well, that's excellent. It's like I didn't even know that was there. So that's what I just said. 1 cubic centimeter is 1 cubic milliliter, right? Or 1 milliliter. 1 cubic decimeter is 1,000 cubic centimeters is 1 liter, and 1 cubic meter is 1 kiloliter. Volume capacity in the metric system. So very similar to what we had done before. An aquarium has a volume of 36,000 cubic centimeters. How many liters of water does the aquarium hold? Okay, so we want liters, and we know that there's 1,000 cubic centimeters in 1 liter. So if we multiply centimeters, cubic centimeters are going to cancel with the cubic centimeters, leaving us with the units of liters. And then we take our 36,000 liters divided by 1,000 for the cubic centimeters, and we get 36 liters. Okay. All right. So hope that was helpful, and I'll see you in the next video.